All right. So the enthalpy of vaporization for acetone is 32 kilojoules per mole. So this is going to, the normal boiling point for acetone is 56.5 degrees. What is the vapor pressure at 23.5? So the normal boiling point means that the vapor pressure equals atmospheric pressure at that temperature, or yes, at that temperature. So that means that our P1, we have a P1 which is 1 atmosphere at a T1 of 56.5 degrees Celsius. And we're looking for a P2 given a T2 of 23.5 degrees Celsius. So this is application of the Clausius-Clapeyron equation, which is just this. Where we're given our delta H for vaporization in the question as 32.0 kilojoules per mole. Okay, so the R, or the gas constant that we're going to use for this, is just 8.314 joules per mole Kelvin. Yep. Okay, that makes sense. Okay, so then, okay, so then we've got a ln P2 over P1 minus 32.0 kilojoules per mole over 8.314 joules per mole Kelvin. Now the kilojoules, we're going to have to multiply by 1,000 joules per kilojoule. And then for our temperatures, we've got 1 over, now these will all have to be in Kelvin. So plus 273.15 is 329.65 Kelvin. And this is, excuse me, 296.65 Kelvin. Okay, so I'm just gonna actually erase this and write it down underneath just for clarity. So that would be 1 over 296.65 minus 1 over 329.65. And these are Kelvin. And if we do this all out on the calculator, we'll get minus 1.30. And so then P2 over P1 is just e to the minus 1.30, or P2 is P1 e to the minus 1.30. Again, we can figure that out on our calculator. So P2 is 1.0 atmosphere times 0.273 or 0.273 atmospheres. Okay, so there's our boiling point at 23.5 degrees Celsius. Or sorry, that's the vapor pressure. That makes more sense. That's the vapor pressure at 23.5 degrees Celsius. Okay, so looking through our solution here. So this is applying all the values, which looks good. And then this looks like a slight calculator error just at the end there, but that's okay. But all the values look about the same. So this looks good.